Hi, my name is Phước Hữu and I would like to present our work, Single Image HDR Reconstruction by Multi-Exposure Acceleration. Cameras are optical instruments designed to mimic the human visual system. An essential but challenging factor for the camera is the dynamic range. A consumer-grade camera can only capture images with relatively low dynamic range, while our eyes can perceive very high one. Images captured by such camera in certain conditions often result in over or underexposed regions. Traditional methods focus on the HDR reconstruction from multiple images, solving the core problem of image alignment, fusion, and tone mapping, yet having a perfect solution. Final HDR image might suffer from ghosting and other visual artifacts due to the object motion I capture. With deep learning, one plausible solution is to use a single image as the input. This is beneficial in that the misalignment problem can be circumvented. We represent attempt in single image HDR reconstruction into two groups. The first are direct methods, which receive an input area and try to read the corresponding HDR. The second are indirect methods, which predict multi-exposure images as the output. We then can use traditional method to reconstruct the final HDR. This work, we follow the indirect approach and propose a novel framework that only uses pair of exposure for training as opposed to reverse work. Let us revise our camera pipeline for image formation. We generally model an image I from the in-camera image processing pipeline as a function f of x that transforms the scene irradiance E iterated over the exposure time t. The line measurement x is linear and based on the physics model of light transport. And the function f of x is composition of all nonlinearities that occur in the in-camera signal processing. To perform HDR reconstruction, our goal is to input the image formation model to recover sensor irradiance E. This is an imposed and challenging problem because some steps in the function f are irreversible. To address this problem, we offer the data-driven approach and propose to use the CNN to learn the pipeline inversion. Our method is based on the assumption that images taken with the same camera in the same scene will share the same underlying scene irradiance. Given a pair of images with two different exposure, we predict a latent invariant representation from this by enforcing the exposure pair to have the same representation when scaled by a factor. This representation can then be scaled and passed to the up or down exposure net to reconstruct different exposure images. To perform inference, we let the network take a single area image as the input and produce multiple up and down exposure of that input, then aggregate the images to form the final HDR. We conduct the qualitative comparison with other state-of-the-art methods. Other methods produce artifacts in extremely high dynamic range regions, while ours can recover details in the region pleasantly. We also conduct the quantitative comparison using form metrics. Our methods either outperform or on par with other methods on these metrics. We use multiple tone mapping operators on the genetic HDR images to validate the consistency in the quantitative result. Our proposed method outperforms all the others. Quantitative comparison on the bracketed images generated by our model versus the other. The overall structure of images is well reconstructed and perceptually similar to the reconstructed images for our method. User study is conducted to evaluate human reference on the qualitative results so that we are preferred in the both tests by approximately 70% of this user. Our method can also generate arbitrary exposure values that are not in the training set. In summary, we propose a novel end-to-end trainable neural network, introduce an objective function that utilizes pixel irradiance, and conduct comprehensive and quantitative evaluation. Thank you.